All right, there's going to be a couple of videos here that have to do with the unit circle. And we're going to start out here and talk about what it means to measure an angle with radians. This is something you need to pay attention to with your calculator. Your calculator has two different modes that it does trigonometry with. One is degrees, one is radians. Up to this point, you've wanted it into degrees, and now we're going to have to pay attention to the problems that we're working on, decide whether we want to be in radians or in degrees. So the idea of measuring an angle in radians, I'm going to kind of demonstrate this with a geometry, or with a Desmos. So let me pull that Desmos, or Geometry Sketchpad, I guess is what we're doing it with. Okay. And the idea here is that we've got a circle with radius 1. It's marked 1 there. It's measuring with some different units here, but CA is the radius of this circle. It's 6.9 centimeters. And the idea is if we take this angle of rotation and start turning the terminal side around the circle in a clockwise direction, and we go until we are cut off an arc on the circle that is equal to the radius of the circle. Our radius was 6.9, so we're going to shoot for 6.9 here. And when the length of the arc is 6.9, we can see that it's reading the angle and the arc measure both as 1 radian. So a radian is 1 radius unit. It's the distance around the circle that is equivalent to the radius of the circle. Okay, so let's jump back into our notes. So measuring angles in radians, an angle of rotation that cuts off an arc equal in length to 1 radius has a measure of 1 radian. Okay. An angle of rotation of 360 degrees, so if we do a full rotation of the circle, that is equivalent to 2 pi radians, and that should look familiar because that's part of the circumference formula of the circle. It takes exactly 2.2 pi copies of the radius to stretch all the way around the circle one time. Okay? This gives us a conversion tool. I'm going to represent it as an arrow diagram. So if we have an angle in degrees and we want to change it into radians, then our conversion we use here is this idea of the 360 and the 2 pi being together. If we wanted, and that fraction reduces to a pi over 180. And so if we multiply by pi and divide by 180, we take the degrees, divide by 180, multiply by pi, we'll have changed it into radians. If we want to go the other way then, from radians to degrees, and we want to do the exact opposite of that, which is multiplying by 180 and dividing by pi. Very often angles in radians are given with a pi as part of the process, so that means that we're able to cancel a pi out. That's not always the case. Sometimes it's a decimal. Generally speaking, 2 pi is about 6.28, so radians are much bigger units, so it takes smaller numbers to describe them. Okay, so I lost my 2 pi from my notes when I did that little trick, so I'll put that back up there. This isn't part of that. So, example 1, convert 276 degrees to radians. Well, that means we're going to take the 276 degrees and we're going to multiply by pi and divide by 180. Okay. So that's going to be 276 over 180 pi, and we can probably do some significant reducing of that fraction. I think, should have done that ahead of time. If I can divide those both by 4, maybe, 24, 36, yeah, that'd be 69 over 180 divided by 4 is 90, 45. So this would be 69 pi over 45. And those are both divisible by 3, so I can reduce that even a little bit further. And dividing that by 3, I get 23 pi over 15. Okay, is what that one would be in radians. So I want 5 pi over 12 to change to degrees. Then I'm going to take my 5 pi over 12 and I'm going to multiply by 180 over pi. The pi's cancel. We'll try to do 180 divided by 12. See if that comes out nice. 180 divided by 12 is 15. So this looks like it is 5 times 15, 15, 25. This is equivalent to a 75-degree angle. All right. So, an example of one of each of those. There are some of these that we are supposed to get very familiar with because they correspond to our angles in the special right triangles. And we'll see a little bit more of that in the second video, but for now, 0 degrees is 0 radians. Multiplying by 0 is always going to do that for us. You can check and verify these. 30 degrees will be pi over 6 radians. 45 degrees is pi over 4 radians. Pi over 3 is equivalent to 60 degrees. 90 degrees is pi over 2 radians. 120 degrees is 4 pi over 3 radians. 135 degrees is 3 pi over 4 radians. 150 degrees is 5 pi over 6 radians. 180 degrees is pi radians. 360 degrees is 2 pi radians. Some other ones that we can get in there, but these are ones that we're going to become very, very familiar with. Okay. So, let's talk about a unit circle. A unit circle, the unit part means that the radius is 1 and is going to be centered at the origin, just like our angles of rotation are. And our interest is in where the terminal side of an angle of rotation intersects this circle. Okay, I thought about several ways of trying to do this and just kind of settled on a tell me everything about 51 pi over 36 radians. This is going to take a little while because there's a lot of information about to hit you. So take it slowly. First thing we have to do is figure out where in the heck 51 pi over 36 radians is. Off the top of my head, I don't know that. I know I speak degrees much better. I see degrees better, so I'm going to change. I'm going to start by changing this into degrees. So that's going to multiply by 180 and divide by pi. So my pi's will cancel. 36 goes into 180 exactly 5 times. 5 times 51 is 255 degrees. So I know this is 180 degrees over here. This is 270. So I'm about 15 degrees short of getting there. So I believe that is going to be 255 degrees, or 51 pi over 36 radians. Now, this creates what we call a reference triangle in here. So our reference angle, as we defined, was drawn from a point on the terminal side of the angle perpendicular to the x-axis. So this is that triangle, and this angle that is inside of here, if it was 15 degrees short there, then that's going to make that a 75-degree reference angle. Okay. This is on a unit circle. This has radius 1, which means that the hypotenuse of this triangle is 1. What I'm interested in is, where is this point? Okay. Well, I've just drawn a right triangle in here, and I know one angle, and I know the hypotenuse, which means I could use trigonometry to find the other sides. I'll call this side x, and I'll call this side y. For the 75-degree angle here, x is the adjacent side. The hypotenuse is 1. Adjacent and hypotenuse is cosine. So I could write that the cosine of 75 degrees is the adjacent side divided by 1, so I don't have to do that. It tells me that this x here is actually equal to the cosine of 75 degrees. Okay. If I wanted to find a y, the y is the opposite side, so that would say that the sine of 75 degrees is equal to the length of the opposite side divided by the hypotenuse, which is 1, so it says this is equal to the sine of 75 degrees. Now, this x should actually, if I did cosine of 75, it would give me a positive number, but this point is located in the third quadrant, and I know in the third quadrant my x-coordinates should be negative, and my y-coordinates should be negative. And so this point, okay, and we could check this and find out, but this x, this should be negative, and this should be negative, and I would find that those are exactly equal to what I would get if I did the cosine of 51 pi over 36 radians, and this is the sine of 51 pi over 36 radians. So the x-coordinate of this point out here is the cosine of the angle. Okay, my angle again to begin with was 51 pi over 36, which is equivalent to, what did we say, 255 degrees. And I have a sine of 51 pi over 36. These are the exact coordinates of the point where the terminal side hits this circle out here. So the coordinates are the cosine of the angle, comma, sine of the angle. And I expect them, because this angle is in the third quadrant when it intersects the circle, the terminal side intersects the circle in the third quadrant, those should both come out to be negative numbers if I put my calculator into radian mode. So I'm going to go mode and radians on here, and I'm going to check this. My cosine of 51 pi over 36, just so that you can check this as well. This is negative 0.2588 and some other numbers. And my sine of that same angle is negative 0.9659. Okay, so use your calculator, check that you get those. I would say if this is about a half, I did a pretty good job of drawing that in there. It probably should have been squeezed in there a little bit closer, but this is definitely down there close to the -1. So everything seems to be checking out there. Let's try another one of those. Let's look at -5 pi over 12. So again, let's convert it to degrees just so that we can see where we should draw it. -5 pi over 12 times 180 divided by pi. The pi's cancel. 180 divided by 12, I think we did that before and got 15. And so -5 times 15 is -75 degrees. So from, I would be turning clockwise because it's negative. That's 45, this is 90, I'm thinking right around in here, something like that is where my angle is. I can make my reference triangle in here. Okay. That's going to be about a 75-degree angle in there. Because I am in the 4th quadrant, I expect my x-coordinate will be positive and my y-coordinate will be negative. And if I am trying to find those, the x and the y, the x is still the adjacent side, so that is cosine. And this time I'll just go with my cosine of -5 pi over 12 is equal to the opposite side, which is, or the adjacent side, sorry, that's my x, divided by the hypotenuse, which again, because I'm in the unit circle, the hypotenuse is 1, so it's x over 1, and the x-coordinate is just the cosine of -5 pi over 12. And my y-coordinate, I'll do that one in a different color. My y is the opposite, so that would be the sine of the -5 pi over 12 is equal to y divided by 1. So my y-coordinate is just the sine of -5 pi over 12. So these are the coordinates of those points. If I check with my calculator, my cosine of a negative, I'm worried here because my x-coordinate was supposed to be positive, but when I do the cosine of -5 pi divided by 12, I get positive 0.2588. So a little bit, I probably drew that angle not steep enough in there because mine's looking more like it's at halfway along there. And if I do the sine of that angle, I get -0.9659. The x-coordinate is positive, the y-coordinate is negative, just like it's supposed to be. So I can determine those points on the x-axis by doing the cosine of the angle to find the x-coordinate and the sine of the angle to find the y-coordinate. This is where I'm going to cut this video off at this point, and there will be a supplement to this one.